Hi everyone, this is Mrs. Eggerding and you are watching video 7 from Unit 1 for Advanced Algebra 2. We're going to talk about using some notation that you're going to see throughout the year, set and interval notation. The book really likes using set notation when it gives answers in the back, and interval notation is just really common throughout everything. So we're going to start with set notation. Okay. Set notation describes a property that's common for everything in a given situation. So this is an example of set notation here. It says X. This stands for all x's or all values. And the up and down bar is read such that. So we have all values such that x is an odd number less than 10. And we can actually list the elements of the set. And to list the elements of the set, we would list all the odd numbers less than 10. So 1, 3, 5, 7, and 9. Okay. Now on the other side, we're going to do some examples where you write it in set notation. Here's all positive multiples of 3, and the set notation would be the squiggly bar, all values such that x is a positive multiple of 3. Okay? And so this one you can just write using the words. Another type of set notation can use math notation. So all values greater than 28 in set notation is all values such that x is greater than 28. Okay, so those are two examples of writing things in set notation. Interval notation, we're going to start by looking at a graph. And so here we have a graph, closed circle at -3, open circle at 5. And interval notation is a way to say, okay, here's where I start, here's where you end. It's left to right. And so in this example, we're starting at -3, we're ending at 5. And you'll remember from Algebra 1 that the open and closed circles mean things. An open circle means you don't want to include the answer. The closed circle means you want to include it. Interval notation takes that into account. Since we want to include the -3, we're going to use a closed bracket. So that means you want to include -3. The 5 is not included, and so we use the open bracket to say we don't want to include, not included. So we say from -3 to 5, the -3 is included, the 5 is not. Okay. Here's an example that has the graph going in both directions. Okay. So if we're going from left to right here, we're actually going to have to do it in two pieces. And this first piece, as I go left, I'm actually going towards -infinity. And on the right, I'm stopping at -6. The -6 is included. Infinities always get an open bracket. The second piece is starting at 2. It's included. And it's going to the right forever. And to the right forever is going to be a positive infinity. Infinity always gets an open bracket. Often in the middle of this, you'll see a U, and this U is a symbol for union. Okay, where it's both this interval from -infinity to -6 along with the interval from 2 to infinity. Okay, so that's interval notation from a graph. Now if I want to talk about an interval from an inequality, we can think of it a similar way. So all the x's that are less than or equal to negative 12. And in fact, I am going to go ahead and use a graph to help me with this. If I'm at negative 12 on my number line, I would have had a closed circle, and I'd be coloring all the way to the left. So if I want to, again, interval notation goes left to right. On the left is negative infinity. On the right is negative 12. Negative infinity always gets an open bracket. Negative 12 is included, so it gets a closed bracket. And our last example, I wrote it in set notation. So this is just all values such that x is between 17 and 32. All values that are between 17 and 32. So on my number line, I'd have 17, I'd have 32. 17's included, 32 is not, and I want all the values in between. I'm going to use my interval notation from left to right. I'm going to start at 17, end at 32, include 17, not include 32. Okay, so that's set notation and interval notation. In class, you should have gotten a worksheet, has both definitions and has some examples for you to work through, and that's where we'll get started in class tomorrow. Thanks a lot, and we'll see you later.